All right, let's hit it. Solving logs. So we take our equation. Log equals log. See, log of the same base, log of the same base, just like exponential equations. If they got the same base, drop them. We're going to set the arguments equal to each other. Now, one thing to be careful about with logarithms, you always have to check your answer. Now, we're not looking so much for something that we get and then we get a number and plug it in and it looks wrong. We're looking to make sure the argument is positive. We cannot have a negative argument. If we have a negative argument, it just can't happen. It's not in the domain. If I plug 9 in here, that's positive, we should be good to go. You can check it out. 45 plus 9 is 54. 54 is 6 times 9 as well. We're good. Check this next one out. Log base 2, set the inside parts equal. Negative 42 equals 6n. Here's what I did, minus 43, plus 4n, plus 4n. All right, so then we're going to divide by the coefficient. And negative 7 is n. All right, let's see. If I plug negative 7 into here, I get, I'm not sure, let's find out. 1 minus 4 times negative 7, 29. 2 times negative 7 plus 43, 29. We're good. It checks out. I'll definitely get all of these. Same kind of thing here. Let's solve it real quick. I think this might be extraneous. Oh, no, it's not extraneous. Oh, yeah, it is. 3w to both sides. I get 6 is equal to w. Looks good, right? Except if I plug 6 into here, I get negative 12. 9 to what power equals a negative who cares what? It can't happen. That's why our domain is bigger than 0. Our arguments can't be 0 or less. They have to be a positive number. And if we plug a 6 into here, that makes not a positive number. And we're back. So if we look at this next one, notice we have more than one log, right? Guess what? Use your log rules. We're adding, so we're multiplying the arguments. 4 times y plus 5 equals 72. Distribute or divide, I don't really care which way you want to do it. It's a freaking linear equation. You should be able to do these by now. 4y is 52 and y is 13. If you're having trouble with linear equations, go practice. Khan Academy, something, I don't know. But linear equations should be almost mental math for you by now. Let's find something more interesting. Oh, we'll check it. 18, yeah, we're good. I'll do that one in a second. Let's do this one first. Okay, so we got a power and we got subtraction here, right? Quotient rule and product or power rule. Left side, don't move it. Leave it alone. Can't do a thing to it. Don't try. Right side though, we got log base 3. 6 to the second power is 36. Divided by 4, we can I'm going to let you do, you can skip the steps, 36 over 4. You can put the 9 there if you want to. Don't put equals 9 right here, though, because that's not right. But now, whenever we write out our arguments equal to each other, you can just put the 9. You get 2p is 14, and p is 7. Check it out. 14 minus 5, yeah, that should be all right. And b's, yep, no, we're good. All right, let's look at this one. No rules to worry about, but we do have m squared equals 18 minus 7m. What kind of equation is that? 1 second. And we're back. So what kind of mother function is this? Quadratic mother function. All right, how do we solve those? Yeah, mode 5 in the calculator. Quadratic form if you don't have the right calculator. So get it in standard form. Make sure, use inverse operations to get it over to one side, make it equal 0. I'll try and put that as, C right there. Got to get over equal 0 first. Then you can do mode 5 3. Or the quadratic formula if you feel like it, or factor using the AC method. I don't care how you solve it. I'm not testing you on quadratics, I'm testing you on logarithms. Yeah, those. 2 and negative 9. So write it out, m equals 2, m equals negative 9. Now, let's check our answers. If I plug in 2 here, that's 4. That's 18 minus 14 is 4. We're good. Negative 9, on the other hand, that's 36. If I do that, that's going to be a negative something or another times a negative. That's 63 plus 18. But what did I say 36 here? I think I said 36. Wow. Yeah. No. 18 minus 7. Let's go ahead and use the calculator. Is 81. And negative 9 squared is 81. So we're good. Both of them work. No extraneous solution there. Woohoo. And do the same thing with this. We got product rules. That would be 2k squared equals k squared plus 16. I think you can get an imaginary number there. No, 4, negative 4. Yeah, try it out yourself. Now, what if it's not log equals log? What if it's log equals a number? That's when you're going to use that little thing where you rewrite it as an exponential. Again, check for exchange roots. 2 to the 6 is x minus 4. So 64 is x minus 4. 68 is x. Same sort of thing over here, but first it's got to equal a number. It's not equal to a number yet, so add 7 to both sides. I'm not going to write these parentheses, but if you need to, go for it. If you check 60, we can check. Log base 2 of 68 minus 4 is 6. Again, the main thing, check the argument. Make sure your argument's not negative. You should be all right. Nope, that's not base 3, so 3 to the 4th equals 4x plus 8. 81 equals 4x plus 8. 1 minus 8 is 73. Oh, 73, that's not a nice number. Huh. Divided by 4 is 73/4. Let's check it. Oh, yeah. 73 over 4 times 4 is 73, plus 8 is 81. That would give you a 4 minus 7 is -3. Yes. Okay. It works. Let's look for some interesting ones. Why not? Product rule. Multiply them together. Still log. So 10 to the second power is equal to distributive property 2x squared minus 10x. Okay. 1 second. Okay, hopefully I didn't link these two videos together. If I did, well, just split it up and make it really large. Yeah, whatever. Get it, it's a quadratic, get it in standard form. 2x squared minus 10x. 10x minus 100 equals 0. Multiply 3 works nicely. 2, -10, -100. And if you get something nasty, which we didn't, 10 to -5. If you got some radicals in there, you probably want to go back and check and make sure you didn't screw up. We didn't get radicals, so it should be all right. Now, obviously, if I plug in a negative right here, that ain't going to work. So this guy's extraneous. Let's check out the 10, 20. This one is 10 minus 5 is 5. We should be good. That's all you need to check for. Make sure it's in the domain. You'll be all right. That guy works. Anything more interesting? That's it. We'll do one more. Yeah, there's not really much you can do with these. I guess number 14. That's going to be x squared divided by 4, right? Our rule, quotient rule. Again, understood base of 10. Wow, 10 to the second power. So that's 100. Multiply by 4, that's 400. Is x squared. Don't forget to take plus or minus when you do the square root. X is 20. And yes, you could have used the quadratic formula in here. X equals -20. Check it out. Negative certainly does not work. Positive should be fine. All right. See you in the next video.